Hey everyone, welcome to your optional lesson. So again, you don't have to do this assignment, but if you do choose to do it, it will replace your lowest grade. So if you have a 0 on something, or if you have a 50, this will replace whatever that lowest grade is that you have in the class. This is going to be partial fraction decomposition. You won't need this until you get to Calculus 2. And I do believe you will be taught this in Calculus 2. This used to be taught in your pre-calculus class. And here recently they took it out. And so it is taught in your Calc 2 class. But even though that's a little ways away, and you will be taught it, I thought it was a good idea just to kind of expose you to that idea. So, example 1 says to add. So we're going to add these two rational expressions together. The easiest way to do that is to cross multiply, and that will be on the top, and then to multiply the bottom and bring that over. Okay, and we're going to be doing that quite a bit as we go through this lesson, and that's just kind of the easiest way to do it. So we're going to do these two together. Okay, so I've got 3 times x minus 3 plus, because there's a plus in the middle, go this way. So 2 times x minus 4, and then multiply the bottom together. And I've got x plus 4 and x minus 3. Okay, we're going to be doing that this whole lesson. So now let's just simplify it. On the top, I can distribute. So I've got 3x minus 3. Distribute the 2, so plus 2x plus 8. All over, we're going to FOIL on the bottom. I'm going to get x squared minus 3x plus 4x minus 12. So my final answer is 5x minus 1 all over x squared plus x minus 12. Okay, that's not too bad, right? Well, unfortunately, we started with that one because we are doing the reverse procedure. The reverse procedure, starting with this rational expression, though this one here, and writing the sum or difference of two simpler fractions, 3 over x plus 4 and 2 over x minus 3, is referred to as partial fraction decomposition, and the two simpler fractions are called partial fraction. So I'm literally wanting to do this opposite. We're going to be given this, and I need to get it to this fraction, or to this rational expressions where we're adding those together. So here we go. Example 2, we only have 3 examples here. And I honestly just think the easiest thing to do is just to jump in and do some examples. So that's what we're going to do. So write the partial fraction decomposition of the given rational expression. So if this bottom portion is not factored, we need to factor it first. So my a times c is negative 28. My b term is negative 3. What adds up to negative 3 and multiplies to negative 28. And that's going to be negative 7 and 4. So this can be rewrote as x over x minus 7 and x plus 4. A couple of your homework problems, I think the first 2, there's only 5. Okay, so the first 2 problems will already start in factored form. Your last 3 problems, you will need to factor. Once you do that, it does not matter what's on the top. this becomes a over your first multiple, x minus 7, plus b over x plus 4. Okay, again, it does not matter what this is. You're doing a over the first multiple and b over the second multiple. Then I need to add these together. And so we're going to do what we did right here. Multiply diagonally, that goes on the top. The bottom multiplied together is on the bottom. So I've got a times x plus 4 plus b times x minus 7, and that is all over these two together. Okay. So after that, it's almost like you're not looking at this middle portion here. You have this expression equals this expression here. Okay, and I'm going to write this out, but you don't, I wouldn't on your paper. But what we have is this one, x over x minus 7, and again, don't write this because I'm going to erase all of it, equals this one here, a times x plus 4 plus b times x minus 7 all over these two. So if this was my equation here and I had to solve, the first thing we would do is want to get rid of these denominators. So to get rid of them, we would multiply by x minus 7, x plus 4, x minus 7, x plus 4, and then what happens? Cancel, 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 cancel. Now I'm left with x. Cancel, 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 and now I'm left with the top, and that's always going to happen. So my next line here, after I erase all of this, okay, is going to be just this equals this. So I've got x equals a times x plus 4 plus b times x minus 7. Okay, because again, we're doing this equals this, because they have the same denominator, they cancel out. So now here, I'm going to show you two different ways to solve it. I'm going to show you the way I prefer, and then the way that I was encouraged to teach you. Okay? So the way I like, let's go ahead and do a different color, shall we? Okay. The way I like is once we have this equation here, the whole goal of this is to solve for a and b. So I'm going to pick a number that I know will cancel out this a portion so I can solve for b. So what number do we put in here to equal 0? And so you could actually, set you up an equation. Subtract your 4, and we're going to get x equals negative 4, and that will get me 0 in here. So when x equals negative 4, and now plug it in and solve. So plug that into this x, to this x, and into this one. So I've got negative 4 equals, well, like we've said, negative 4 plus 4 is 0. And 0 times a, that just wipes out that whole term right there. So that's gone. So now I'm just left with this portion here. So we've got b times -4 minus 7. So we've got -4 times -11b. Divide both sides by -11, and b equals 4 over 11. Do the same thing to get this term here to cancel out. What do you have to plug into x to make that be 0? And that's going to be 7. And again, you can set up that equation if you need to. But I'm going to have x equal 7. So when x equals 7, plug that in again to all three x's. So I've got 7 equals a times 7 plus 4. And then when you do 7 minus 7, you get 0, and 0 times b is 0, so that cancels out. So that's my whole equation. So I've got 7 equals 11a, divide by 11, and a equals 7/11. So now plug in your a and your b, and my final answer will be 7 over 11 x minus 7 plus 4 over 11ths x plus 4. Okay, that's my preferred method. And if you kind of notice, we got a complex fraction here, right? That's what we did last lesson, and it's okay to leave these in complex fractions. Let's look at how I was advised to teach you. Okay. So the second way to teach you is the whole reason that this right here works is because this is a system of equation. So this goes back to your module 1 of pre-calculus. If I rewrite this right here as x plus 0 equals the same thing, actually, and I'm going to distribute my a and my b. So this becomes ax plus 4a plus bx. And I'm going to erase this just to try and get this to all fit here. Let's try again. So I'm going to rewrite x as x plus 0, distribute your a, ax plus 4a, distribute your b, we get bx minus 7b. From here, set up your systems of equations. So everything that has an x goes together, and you're looking at the coefficient here. So that's the same as 1x. So I've got 1 equals, that's a 1 right there, right? So that's just a plus, there's a 1 here, so that's just 1b or just b. And then everything that doesn't have an x. And again, I'm looking at those coefficients with those. So that's 0 equals 4a minus 7b. So you could do this by hand, but you should have been taught how to put this in your calculator. So use your matrix and use your RREF. Now be careful when you put this into your matrix. You need a 2x3. Remember, when you put this in, your equals goes right here, right? So when you write this, we're writing 1, 1, 1. So I guess it doesn't really matter too much in the top, but the bottom is going to matter. So in the bottom, you've got to write 4, -7, and then 0. 4, -7, 0. Okay, because that's where your equal sign goes right here. So use your RREF, put that in as a 2x3 matrix. When you get that, you're going to get fractions, but just do your arrow fraction button, and the matrix you should get is 1, 0, 7/11, and then 0, 1, 4/11, which is exactly what we got right here, right? This column right here represents your A. So that means 7/11 is your A. This column here represents your B. So 4/11 is your B. Okay, I was advised to teach you this, and that is easy. It's not bad, but I do prefer this way here. So let's try 2 more examples. In part B, I'm going to use this method, and then in part C, I'm going to use this method. Okay, so on B, we need to factor this first. There's not a GCF, and so because A is greater than 1, we do have a hard one. So my A times C is -12. My B is -11. What adds up to -11 and multiplies to -12? And that's going to be -12 and 1. So we're going to use that to rewrite this middle term. So I've got 3x squared minus 12x plus x minus 4, and factor by grouping. So in this first group, we can take out a 3x. That leaves me with x minus 4. So notice that's exactly what I have here. So my GCF is 1 to leave me with an x minus 4. So this factors to become 3x plus 1 and x minus 4. It does not matter what's in the top here. This will always be A over 1 multiple plus B over the second multiple. So now let's combine these. So we're going to go diagonally. So I've got A times x minus 4 plus, go diagonally here, B times x, 3x plus 1, and that's all over these two together. Okay, so after we do that, we're kind of not looking at this middle section anymore. These two here equal each other. Notice they have the same thing on bottom, so those cancel, and I'm just left with what's on top. So I have 6 equals A times x minus 4 plus B times 3x plus 1. So we're going to do number 2 here. If you wanted to do number 1, you figure out what can you get to make this equal 0. So you'd have x equals 4. And then what can you do to get this equals 0? If you set that equal to 0 and solve, then you'd have x equals negative 1/3. Okay, that's how you would do it by these two methods here. But we're doing method 2. So this 6 is going to become 0x plus 6, just so I know what goes with my x. Distribute. Let me move this up some. Okay. Okay, so we've got a to the x minus 4a plus 3bx plus b. So write your systems of equation. Anything that has an x is going with us. So this becomes 0 equals a plus 3b. And then anything that does not have an x goes in the next one. So 6 equals negative 4a plus b. So now take this here and write it in a matrix. So we're going to RREF. And your matrix looks like 1, 1, 3, 0, negative 4, 1, 6. Okay, because that's your equal sign. So all of this has to come on the very right. Once you RREF, you're going to get decimals again. Once you get that decimal, you need a math and then arrow fraction. And the matrix you should get is 1, 0, negative 18 over 13, 0, 1, 6 over 13. Okay, this is again your A column and your B column. So this is telling you that this is, sorry, that this is A and that this is B. So I'm kind of out of room here, but you're plugging that into this A and into this B. So I'm going to write this sideways. I'm sorry. We get negative 18 over 13 all over 3x plus 1 plus 6 over 13 all over x minus 4. That's my final answer. Okay, sorry that's sideways, but that's the best room I had. Okay, last example. Okay. I'm going to try and write this one as small as possible, but I don't know if it's possible. Okay, the bottom here needs to be factored. And so notice I have a 3 here. That means I'm going to have 3 factors. So what I can do is take out an x. And that leaves me with x squared plus 2x minus 15. And then that will factor to be x plus 5, and x minus 3. What multiplies to this and adds up to this. So this becomes negative 9x plus 75, and I need to scoot this over. Negative 9x plus 75 all over x times x plus 5, x minus 3. Now this time, because I have 1, 2, 3 multiples, I have an A, B, and C that I have to solve for this time. This is going to be like your 5th problem in your assignment. So this becomes, and again, it doesn't matter what I have here, right? It becomes A over X plus B over X plus 5 plus C over X minus 3. Okay. Now this time, when I multiply, I'm doing A times both of these here. And then B times both of these here. And then hopefully you're seeing the pattern, C over these two here. Okay, that's an x plus 5. Okay, and then this is all over x plus 5, x minus 3. So it's like I'm not looking at this middle one. I have these two here set equal. Because they're over the same denominator, they cancel and I'm left with just what's on top. So my equation is negative 9x plus 75 equals all of that. And all of that is all of this. Okay, we are using option 1, which means I'm trying to get some zeros in here. So, the first thing is if I have this, oh crap, okay. If I have this multiple here of x, then x just equals 0. So when I put in x equals 0, that's going to zero this out. So I'm just left with 75 equals. We have a times, we got 0 plus 5, so just 5. And 0 minus 3, so times negative 3. But when I put a 0 here, that's going to zero out this entire term. And when I put a 0 here, that's going to cancel out this entire term. So that's all I have. So now solve for A. We have 75 equals 5 times negative 3 gives me negative 15a. Divide by negative 15. And a equals negative 5. Okay, so let's look at that next multiple. What do I have to plug in here is a -5 to get that to zero out. So x equals -5. So put that in to this x here. So I've got -9 times -5 plus 75 equals, when I put in a -5 here, that turns into 0. So this whole thing here cancels. So then I have b times -5. -5 minus 3 gives me a -8. And then when I put in a -5 here, that zeroes out, so that whole term also cancels. -5 times -9 is 45. 45 plus 75 is 120. On this side, we've got 40b. Divide by 40, and b equals 3. And then lastly, for this multiple here, we need a 3. So when x equals 3, we're going to have -9 times -3 plus 75 equals, we're going to have a 3 minus 3. That zeroes out. That's canceled. And 3 minus 3 is 0, so this cancels. So all I have left is this other, is the c portion. So I've got c times 3. And then 3 plus 5 gives me 8. So times 8. So this gives me positive 27. 27 plus 75 is 48. This is going to be 24. And so here, c equals 2. So once we have our A, B, and C, I don't know if I can. Yes, I can. Now that we have A, B, and C, take this here and plug in your A, B, and C. So my A is -5. So I've got -5 over x plus my B is 3. So 3 over x plus 5. And then my C is 2. So 2 over x minus 3. And so that is my final answer. All right, so hopefully this gives you a little bit of a taste for whenever you get into Calc 2, and you will need this for integrals. Hopefully you didn't need this lesson. Hopefully you just love math so much and were curious about it and just wanted to do it. But if you needed it, I hope it helps your grade. And guys, it's been fun. If you have any questions about this, or even when you get into calc, I will be more than happy to help you if I can. I'm not a calculus expert, but if I can help you, I would love to help you. Best of luck, and hopefully whenever this pandemic is done, I'll see you around. Bye, guys.